1.2, day number 2. I'm going to talk more about representing functions. Objectives will be slope function, area functions, and transformations, and intersecting functions. So let's jump into the idea of this slope function. So g of x is a slope function representing the slope of f of x. So let's take this and analyze this for a moment. This portion of the graph has a different slope than this portion, which has a different slope than this portion. So when considering that, if I were to graph the slope of the function based on these three intervals, well, the slope of the green portion would be 1. The slope of the blue portion would be 0. And the slope of the purple portion looks like it would be negative 2/3. So the portion that I just drew there is the slope function. So let's go ahead and write out the piecewise function for that. So we said that if x was less than 0, then its slope was 1. If x was between 0 and 3, the slope was 0. And finally, if x was greater than 3, then the slope would have been negative 2/3. Now, I want to point out something pretty important here, is that we have these open holes here at the ends, and the reason for that is because at these points there is no slope, right? Because it's a corner or a abrupt change, that slope doesn't exist at those points. So therefore, it is important that those would be open there. Okay, so let's sketch a graph of the following and then find the slope function. So I should have provided myself a nice little grid here, but I didn't. So I'm going to go ahead and do this. This first one, negative x minus 1. So negative x minus 1 would be a line, preferably a line that would look like that. Less than or equal to negative 1. So at negative 1, I would put a nice point there and then go to the left. Since x is less than or equal to negative 1. Okay, the next portion, the equation x plus 1, I would draw a line like that and just fill in the appropriate interval from negative 1 to 0. So it's inclusive there and not inclusive there. Okay, continuing on, let's move on to this piece. Negative x plus 1, well, that's a slope of negative 1 and a y-intercept of 1. Not inclusive at 0, but it is inclusive at 1. And then finally, negative x minus 1, so a y-intercept down here of negative 1 and a slope of positive 1. It looks like greater than. It's not inclusive at that point. So now we can come up with a slope function, g of x. It'll be 4 pieces. Right? I'm just going to go with the same intervals I had before. The slope there is negative 1. The green portion is where x is greater than negative 1, less than or equal to 0. Looks like the slope there is positive 1. The blue portion, where x is greater than 0 and less than or equal to 1, was negative 1. And I'm running out of space here, but looks like the slope is positive 1 if x is greater than 1. That's the slope function. Okay, now let's talk area function. So let's write a piecewise function for f here. Okay, so f is going to take on 2 different possible functions depending on where it is in the interval. So on this interval from 0 to 3 takes on the equation of 2x. So x is less than or equal to 3, less or greater than or equal to 0. On the next interval, and really we're not going to limit that interval, but we'll say x greater than 3. It looks like the value for y would be 6. So let's find the area if x is 3. So what does that do? Well, what that does, the area function, is it starts at 0 and it accumulates up until that x value. So a of 3 would be the area from 0 to 3. Okay, so I want to talk about finding that real quick in general terms. Looking at this, anywhere from 0 to 3 would be a triangle, so its base would be whatever its t value is, right? Whatever the value is. So in this case, it'd be 3. So the base would be t, which in this case is 3. The height of the triangle would be whatever f of t is. And in this case, f of t equals 6. So to find, in general terms, to find the area, if x is between 0 and 3, what we'd do is we'd take 1/2 the base, we said the base was t, times the height, which was f of t. So in our case here, this should be a t right here. So in our case, a of 3 would be 1/2 the base. Well, the base is going to be 3 because that's our t value, times the height, which is f of 3, which is 6. So 18 divided by 2 looks like that would be 9. Okay, cool. Now, at this point, we're going to go beyond 3, and we're going to go out to 6. So a of 6 is going to be a of 3 plus some rectangle. And now let's think about how we'll develop that rectangle. Let's develop that rectangle. So we've determined that we found the area of this triangle. That triangle is 9. Okay. Now we're going to go out to some value out this way, and we get this rectangle. And it's pretty easy to find the area of a rectangle, but I want to do it in general terms first. So how would I find the area of that rectangle? Well, I'd have to take this number, which is 6, and I'd have to find the distance between 6 and 3, and then multiply it by the height. So for example, let's say we don't know this value. Let's just say it's x. Or excuse me, let's go t with it. Let's call it t. Well, how would I find that width? I'd take t minus 3, and then I'd also multiply it by the height. Well, the height everywhere along this rectangle is going to be 6. So to find, in general terms, to find the area, if t, right, is greater than 3, if it's greater than 3, we would take our area up to 3 plus t minus 3 times 6. Right? This right here will take care of the rectangle. This right here took care of the triangle. So let's do it for a of 6. So that would mean t equals 6. So 6 minus 3 times 6. Looks like that'll be 18. 18 and what we knew this to be, which was 9. So a of 6 would equal 9 plus 18, which is 27. So a of 6 would be 27. Not sure why I circled the 18 there. So let's write a piecewise function for the area. Well, we kind of already did. The area function, we said if x was between 0 and 3, then it would be what we've got here. All right, so that would be 1/2 t times f of t. Now that's not enough information, right? We need to know what f of t is. Okay, f of t, it looks like f of t would have been 2t. So what we have really in reality is we have 1/2 t times 2t. Looks like the 1/2 and the 2 will cancel, and it looks like I get t squared. So the area on the interval where t is between, I keep mixing up my x's and my t's, but just follow with me. This should be a t here. Okay, that would be the first portion right here, first portion of my area function. The second portion, like we said, was the area up to 3 plus t minus 3 times f of t, which is 6. And it's always going to be 6 because it's a rectangle, and that, like we said, f of t up here in that interval would just be 6. So let's simplify that. That's going to be 9 plus 6t minus 18. So I'll simplify that real quick. That would be 6t minus 9. 6t minus 9 on the interval where t is greater than 3. All right, so let's just get this together so we're all on the same page. This right here is your piecewise area function. Okay, let's try another one real quick. I'm going to go ahead and graph f of x off camera, and you can check it out in a minute. All right, awesome. Again, when we do area function, we're going to go from 0 up to wherever we would come back down to 0, right? So we're going to limit our domain on this from 0 to 7, okay? Because otherwise we'll get negative area, So, but there's a graph of f of x. I graphed the first part of the piecewise function there, where t is less than 3, and the second part in blue, where t is greater than or equal to 3. So let's just do a quick go on the area up to 2. That shape is going to be a trapezoid, and the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Let's talk about what the values for base 1 and base 2 would be. I'm going to use the highlighter here. My two bases, right, of this trapezoid are going to be there and there. Okay, so the representation of that, those lengths, well, we know this one will always be 1, and this length will always be f of t. Right? So basically what we have is 1/2 1 plus f of t. And the height is going to be this length, which in this case will be, well, it doesn't really matter, but basically I'm going to use t for that length. Okay, so let's plug in and solve for a of 2. All I'm doing is plugging in a 2 for t. I get 1 plus f of 2 times 2. Well, I need to figure out what f of 2 is. It looks like f of 2 is 3. So if f of 2 is 3, it looks like I'll get these 2's to cancel, and I get an area of 4. Okay. Now to find the area if x is 6, I got some more work to do, right? What I would do is I would need to find the area under the red curve first, which means I would do the same as I did for the area of 2, except put a 3 in there. So let's do that first. Let's talk about what that area would be, and then we'll move on to finding the area from 3 to 6, and we'll add that to that. Okay. So let's do a of 3 first. Looks like what I would do is I'd use this function again, except for t now I'd throw in a 3 instead of a 2. So I would have 1 plus f of 3, which looks like it's 4. So 1 plus 4 is 5. And then it looks like I'm going to multiply again like by 3 here. So 5 times 3 is 15, and 15 divided by 2 is 15 halves. So the area from 0 to 3 is 15 halves. Let's find the area from 3 to 6. Looks like I've got another trapezoid. And it looks like to find that area, I'm going to take 1/2, I'll do this work up here, base 1 plus base 2 times the height. And base 1 is always going to be 3. Base 2 is going to be dependent on what t is, right? So in this case, we've got 6. In general terms, what I would do is I'd write f of t times t. Oh, well, we got some work to do there, because it's not just t, because this is our height right here, and our height would be t minus 3. Okay, so we take 1/2 3 plus f of t, in this case f of 6. F of 6 is 1. and 6 minus 3 is 3. So we simplified this. That gives me the area from 3 to 6, and I add it to the area from 0 to 3. So simplifying this, I get 4 times 3 is 12. 1/2 of 12 is 6. So it looks like I get 6 here. 6 is really 3/3. So, excuse me, 6, wow. 6 is 12 halves. Okay, if 6 is 12 halves, let me make sure I did this right. So 3 plus 1 is 4. 4 times 3 is 12. 12 divided by 2 is 6. Well, I'm going to put it in simplest terms here. Here we go. So I get 27 halves for A of 6. Okay, excellent. I'm going to go ahead and lay out a little bit of what we had already done, and then I'll talk through it for the area function here. Okay, before I get into the area function here, I found a mistake I made earlier. Right here, base 1 wouldn't be a 3, it'd be a 4. So that would make it 5 times 3 divided by 2, which isn't 6. It's going to be 15 halves. So I'd really have 15 halves plus 15 halves, which is going to be 30 halves, which would be 15. So a correction on my part. Okay, so down here, let's look at a piecewise formula for the area function, right? So we determined that we're going to have a trapezoid for anywhere between 0 to 3 for our t value. Therefore, we took 1/2 base 1, here's base 1, times base 2, times the height, right? The height was the distance between 0 and wherever we're going to, right? That was the basically traveling along the x-axis. So if I simplify that real quick, I get 1/2 of 1 plus f of t. What was f of t in the actual function? Well, f of t was t plus 1 in that interval. Okay, so t plus 1 goes in here, and we multiply by t. This is good for this interval 0 to 3. So let's simplify that. That would be 1/2 of t squared plus 2t on that interval from 0 to 3. You can check algebra on that if you want to. I don't think I messed that up. Okay, likewise down here, I'm going to actually do some simplifying here. We said 4 was the output at f of 3, right, where one interval stopped and the next began. Okay, there is something I'm missing here, so hopefully you catch it, but I'll catch it in a moment if you don't. Okay, and then we're going to take f of t as our second base. F of t in the second piecewise function is negative t plus 7. So negative t plus 7. And multiply that by t minus 3. Now there's one thing I'm forgetting. I forgot to add to this the area that I had from the previous portion, right? Accumulating that area from 0 to 3, which we had said was 9 before, right? This is a of 3. So let's do some simplifying here. Whoops, I'm sorry. It's not 9. I goofed that up. I think it was 15 halves, wasn't it? Yeah, it was 15 halves. Let's check and make sure. The area from 0 to 3, yeah, it was 15 halves. There we go. Okay. So we're going to add that area plus the next one. Now let's do some simplifying with some algebra here. This would be negative t plus 11 and t minus 3 and 15 halves. So let's do a little foiling here. That'd be negative t squared. 11 plus 14t minus 33. Okay, and then let's add 15 and pull out that 1/2. Okay, so let's do that. Combine some like terms here. It looks to me like what we would get for this portion of the piecewise function would be, I'm going to leave that 1/2 on the outside. That should be a negative t squared plus 14t and minus 18, which would be good on that interval. Again, boy, with the x's, mixing them up with the t's. Let's get that figured out, huh? Okay, And there you go. Okay, let's move on. Let's talk a little bit about transformations. Parent functions, transformations. Here's your parent function. All that the square root of x looks like, I'm not going to get specific with points, but I do know that it goes from 0, 0 off in that direction. So if I add 3 underneath the root, it brings it over here to the left, 3 units. Oh, come on now. Okay, we'll pretend that's 3 units. And then it flips it vertically like that. It's not perfect, but there's your general sketch of that transformation. All right, parent function here looks like absolute value of x. Right? Here's the absolute value of x, slope of 1, slope of -1 on those two different arms of that. This transformation can be difficult unless you know how to manipulate a little bit. So this tells me I'm shifting up 5, I'm shifting right 3, and this right here is going to be a horizontal shrink. Okay, so let's put the vertex, let's move this vertex because that'll be true. So let's move it to the right 3 and up 5. So right 3 up 5 would put it there. And now these slopes of 1 and -1, all they're going to do is they're going to be horizontally compressed, which is the same as a vertical stretch. So now instead of 1 and -1 for slopes here, now we have 2 and -2 for our slopes. There we go. This is a critical point, though, that you're going to want to be aware of, but that's generally speaking, that's pretty good. Okay, last thing, we're going to talk about these intersecting functions. We're going to talk analytically and graphically, but first what I want to do is just toss a graph up here. The first piece here is a quadratic shifted right 4 up 2. Up 2, yeah, up 2. No stretch or shrink involved, so that should be good. The second graph is just linear in nature. It's got a y-intercept of -3 and a slope of 2. So I'm just going to generally sketch that. It's not well done, but it'll give us an idea. So I'm seeing intersecting points here and here. I'm expecting 2 solutions. So analytically, let's just set them equal. And not forget what's going on with algebra here. This is really x minus 4 times x minus 4. And I'm going to subtract that 2 over to the other side to give me that. When I FOIL, I get x squared minus 8x plus 16 equals 2x minus 5. Subtracting 2x and adding 5, I get -10x and I get 21. If I want to know where that equals 0, I factor. So x and x, that looks to me like a -7, -3. So to me it looks like x equals 7 and x equals 3 will be the x values of these points. So it looks like this will be 3 comma something, and this will be 7 comma something. And the way that I can find those, since I know that this is where both of these equations are equal, is in for x here, I can plug a 3, and then I can plug a 7. So g of 3 is 2 times 3 minus 3 is 6 minus 3. G of 3 is 3. And g of 7 would be 2 times 7 minus 3, which is 14 minus 3, which is 11. On your calculator, what I would suggest doing is I would type f of x in as y1, I would type g of x in as y2, graph it, and then just do a little second, and then press the, I think it's the trace button, yeah. Second trace, and I think it's got options, and like option 4 or 5 is where do these intersect? And it walks you through it step by step. All right, that's 1.2, day number 2 on a bunch of good stuff.